Hi, I'm Kristi, S4's Physicist, and today's physics lesson is all about the states of matter. There are three main states of matter: solids, liquids, and gases. So solids are things like this stone. They have a definite shape. You can see it's kind of a rectangular shape, and they have a definite size as well. It won't get bigger or smaller. The liquids have a definite size, but not a definite shape. This water, when it's in the jug, is the same shape as the jug, but if I pour it into a different container, it doesn't get any bigger or smaller, but it takes a different shape. Gases don't have a definite shape or size. The air around us is a gas, and if I put it into something like this balloon, it will take the shape of the balloon, but it'll also spread out to fill the whole balloon. If I let go of this balloon, the air is going to come flying up. The air then spreads around and fills up the whole room. So these different behaviours can be explained by looking at how the particles in these materials act. So in our solid, the particles are really tightly packed together, and they're arranged in a very uniform structure or pattern. In our liquid, the particles aren't holding on to each other as tightly. They're a little bit more spread out, they have a little bit more energy, and they can move around each other. This lets the liquid itself move. In a gas, the particles are even more spread out, they have even more energy, and they can move about a lot more. This is what lets the gas change shape and change size and spread out across an entire room. We can change things from one state of matter to another, and this is called a phase transition. The difference between each state of matter is how much energy their particles have. So to create a phase transition and change something from one state of matter to another, you just have to give it energy or take energy away from it. I can turn ice back into water by melting it, and I can turn steam back into water by condensing it. But you can change something between a solid and a gas, or skipping out the middle liquid stage altogether. When you go from a solid to a gas, we call it sublimation. Some of you might have seen this before, because it's what happens when we add dry ice or frozen carbon dioxide into water. Going the other way around, going from a gas straight to a solid, is called decomposition, and it's what causes frost on cold mornings. But it's not just temperature that we can use to change something's state of matter. We can also change something's state of matter by changing the pressure. I'm going to show you how this works with an activity that you can try at home. For this experiment, I've got a plastic bottle which I've filled about 3/4 of the way with water, and I've got some matches. Make sure you ask permission from an adult before you do this experiment. The first thing I'm going to do is take my bottle and make sure the lids are nice and tight so I don't end up drenching myself, and then I'm going to squeeze it as hard as I can. When I squeeze it, the pressure inside the bottle, the amount the air is pushing against everything, is going to increase. It's going to get bigger. And that's also going to increase the temperature a little bit. That increase of pressure and temperature is going to give some of those particles a little bit more energy, so they're going to evaporate and become a gas. When I release the bottle, that pressure and that heat energy is taken away. The particles that turned into a gas want to turn back into a liquid. But to do this, they need something to form little liquid droplets around. I'm going to add smoke as an impurity. So I'm going to light a match, drop it into the water, and close the lid as quickly as possible. So now when I squeeze my bottle, some of those liquid particles are turned into a gas, and when I release, they form back into a liquid that's suspended in the air, which we see as a cloud. When I squeeze again, that cloud disappears, and I release, the cloud reappears. And that's the same as real clouds. Real clouds are water that's evaporated into the air and condensed around little impurities in the atmosphere. When we get liquid droplets suspended or held in air like this, we call it a water vapour. And clouds are made of water vapour. In a physics lesson I did last year, we used bike pumps to put even more air pressure into those bottles. This made clouds that were even more visible. But not everything is a solid, a liquid, or a gas. There are other states of matter, like plasmas that the sun is made of, and some things don't quite fit into just one category. This is oobleck, and it's not quite a liquid and it's not quite a solid. It's something called a non-Newtonian fluid, which means it changes its behaviour depending on what we're doing to it. When I apply a force to it, by picking it up, playing with it or hitting it, it becomes more solid. But when I stop applying that force, it becomes more runny, just like a liquid. To make your own oobleck at home, you need some corn flour or cornstarch, some water, a bowl and a spoon. If you want your oobleck to be a different colour, you can also add some food colouring. So first you're going to add your corn flour to the bowl. It doesn't matter how much you add, just make sure that you put twice as much corn flour in as you do water. So I'm going to put 1 cup of corn flour in, so I'm going to use about half a cup of water. We can use other things to apply force to our oobleck too. I've got a little laptop speaker. I'm going to cover it in a layer of cling film and then I'm going to put a drop of oobleck on it. And the vibrations from the speaker hopefully will make the oobleck dance. There are also loads of different types of non-Newtonian fluids that we can find around the home, and I managed to find 2. Ketchup and honey. Now both of these are non-Newtonian fluids, but they're the opposite of oobleck. The more force we apply to them, the runnier they get. And for those slime fans out there, there are loads of different types of slime which are non-Newtonian fluids. Check out our slime video to find out how to make a non-Newtonian slime and the science behind it. So let us know how you got on with the activities from today and look out for more of our physics lessons. Until then, see you soon.